sponsored 6 days online FTP on empowering healthcare with AI, advances, applications, and future directions. And
Recording in progress.
on this day, fourth day, again we have two speakers, two excellent speakers, namely Ms. G. Brenny Shekhar and Dr. Dhanush. The first session will be handled by Brenny Shekhar, and her topic is machine learning for predictive analytics in epidemiology, tracking and managing health outbreaks. So this is the first session, and ma'am is there. I let me introduce ma'am to you, and then I will welcome her to start the session. It's my honor to introduce a visionary data scientist, an AI expert, and a dedicated educator, Ms. Brenny Shekhar. With over 3 years of expertise in machine learning, deep learning, and AI driven analytics, she has developed impactful solutions in fraud detection, predictive modeling, recommendation systems, and image classification. Her work has significantly improved decision making and automation across various industries. She has an impressive command over Python, natural language processing, computer vision, cloud computing, such as AWS, Google Cloud, and MLOps. She has designed end to end AI models, enhancing business intelligence and optimization. Her professional journey includes working at Positive Integers Private Limited and Asset Plus Consulting, where she played a key role in developing data driven frameworks for finance, insurance, and manufacturing sectors. Beyond her contributions as a data scientist, she has also excelled as an assistant professor and mentor and inspired young engineers in the field of electronics and communication engineering for several years. She has successfully developed AI powered applications like sarcasm detection, pneumonia detection, and facial recognition, showcasing her expertise in computer vision and deep learning. I hope she is a lifelong learner. She holds a postgraduate program in AI and machine learning from Great Lakes Institute of Management, along with several certifications in SQL and data analytics. Her passion for innovation, research, and technology makes her an inspiration to aspiring data scientists and AI enthusiasts. So, without further delay, I welcome you, ma'am, for your dynamic and accomplishment over these years, and we wish to hear from you in this session, ma'am. Welcome, ma'am.
Thank you, ma'am. Thank you, Dr. Chitra. So, can you hear me, everyone? And is my screen is visible?
Yes, ma'am. Your screen is visible and you are audible.
Okay. Thank you so much, ma'am. So, good evening, everyone, and thank you, everyone, for joining on time. Uh, uh, to know more about how does machine learning algorithms works on epidemiology or healthcare. Uh, so I just want to clarify a few things. I'm switching my tab, I'm switching my screens. Is it possible to see by everyone? Is the entire screen is visible?
Yes, ma'am.
Yeah, yeah, fine. Right. So thank you so much. Um, so good evening, everyone. Uh, so thank you, Chitra ma'am, for a deep, very brief introduction. And let us start our session. And in today's topic, we are going to focus more on uh, applying machine learning algorithm into epidemiology. So these are the agendas over here. Uh, the agenda here is we are going to see what the introduction of epidemiology, the importance and types of epidemiology, and what are the key matrices we are going to use. And then we'll go through what is predict and predictive analytics, and what are the different machine learning algorithms are available, and what can be the tools used, and finally the challenges and conclusions. So let's start. And as you may aware of, epidemiology is nothing but uh, study of distribution and determination of health related events in populations. So there may be there are many diseases available over the world, and here by using epidemiology we'll be describing why, what, and where the disease occurs, and we find out the analytical reasons behind that, and we may go for some experimental interventions to find out the root cause for the disease. Uh, and there are multiple types of epidemiology, such as like chronic disease epidemiology, which mainly focuses on non-communicable diseases, and there are infectious diseases, like which spreads from person to person, and there are outbreak epidemiology and environmental epidemiology. So overall, epidemiology is something like a study of diseases and the health impact created due to environmental factor or some other impact. So like whenever we do an analysis, if we try to implement machine learning algorithm or data science solution in it, there should be a core objective, and the core objective may be incidence, prevalence, mortality rate, case fatality rate, or reproductive numbers. So the objective may be reducing the disease, or reducing the mortality rate, or like trying to group the peoples based on the similarities, and so on. So with the help of a end objective, we can't be able to build a machine learning algorithm or a predictive analysis. So let's start with predictive modeling. So as I said already, predictive modeling is something like predicting something which is going to happen in the future, or predicting something which can occur in the future based on the past activities. So in real time, there may be multiple things, multiple use cases available, something like sales fraud forecasting, fraudulent detection, grouping of people, recommendation systems, and all those things. But in our section, we are going to see um, how does just a second. Yeah, in our session, we are going to see uh, how does the predictive modeling helps in epidemiology or in the healthcare sector. So, like, so the basic thing we need or require for predictive modeling is a data. So without a data, we can't be able to predict the model. So we should have an objective, and based on the objective, we should be able to say whether we should be able to collect the data, and the data collected should be in line with our objective. If not, we can't go for machine learning algorithm. So the core objective, or the core importance needed over here um is the data. So once we receive the data, like it's logically there are multiple data sets available. If you browse, if you go through the Kaggle data sets, you can able to find multiple data set. But in real time, if you are meant for, if you are working on a specific use case, then it's better to collect the data manually, which gives more impact on the modeling, so that you can collect as much as of data you want. More the data available, better the predictive modeling will be. And so there are multiple things, multiple steps should be followed to do the predictive modeling. So we have to do statistical testing. We should know the business rules. For example, in our case, the mortality rate, or else the target would be the business rules, and there should be decisions, and there should be some assumptions over there. So the aged people are likely to have more heart diseases than youngsters. All those things are the assumptions. So everywhere, whatever the predictive modeling we have, should be should have assumptions, decisions. We learn from the historical data and do the predictors and explanators. So these are the key things we do in predictive analysis. We do data mining, we do statistical analysis. We'll go on depth as we move on to the further topic. We have to do data visualization. We can build machine learning model. Finally, we have to score it. Like we should train a machine learning model. Based on the machine learning model, trained model, uh, the model can be scored on the unseen data set, and finally the decision making can be done. So as I said already, uh, for predictive modeling, the more number of data we have, the better the model will be. So if the data is less, and if the metrics is, if we say like the accuracy is 98 percentage, we are not sure whether the model is the model is good or bad until and unless we test it on an unseen data set. So the better, the bigger the data, the predictive modeling will be performing better. So the data should be arranged, sorted, and apart from that, the domain knowledge should be there. So as an engineers, we may have better understanding of modeling, but if you are working on healthcare, it is better to get insights and medical advices from doctors or medical practitioners, so that those insights can be given as input into the model for better predictive modeling. So logically, machine learning algorithms can be categorized into three broad categories: supervised learning, unsupervised learning, and reinforced learning. So supervised learning is something like we have a data set and we have a target column. And if a data set and target column is available, uh, then we'll try to train the data based on that, which comes under supervised learning. And unsupervised learning is like we have multiple data points, we have the info of multiple people. We try to group the people based on their character. That is called as unsupervised learning. It's something like clustering. And reinforced learning is learning by the machine tries to learn by itself based on awards and non-awards. So here, in most of the cases, we go for supervised learning in epidemiology. And under supervised learning, there are two different subcategories: regression and classification. And regression is something like we have a target column, and the target column is a continuous variable. So if suppose like if the target column is something like having values between 0 to 100, some values 0, 0 0.5, 1.5, 100. In such cases, we say it as regression problem. And in there are scenarios where classification occurs. For example, whether the disease happened or not. In such scenarios, we say it as a classification problem. Uh, so overall, supervised learning is something like there is a target variable, there are multiple columns in the data. So I can show you sample data. So this is a sample data set we are going to see in depth. So here, what we can say, each and every column is as a features. So this is feature 1, feature 2, feature 3, and these are all the input variables. And here, num is the predictor, which says whether a person is having heart disease or not. And this is the target variable. If the target rate variable is having some classification from some defined classes. For example, when we see here, we have 0, 1, 2, 3, 4. In such scenarios, we say it as classifier. If the target column is something like this, something ranges between, which is numeric, then we say it as we say it as a regressor. I hope everyone is clear with this. As of now, anyone having any doubt? Shall I proceed further? Yes,
Yes,
am I
ma'am.
audible? Yeah.
Yes, ma'am.
Yeah, thank you so much. So we'll move on to the next slide. So as I said already, in supervised learning, there is a machine learning algorithm, and that machine learning algorithm, just a second. Okay, so there is some machine learning algorithm, and that machine learning algorithm uh, is being trained on a target column, and the things can be either regression or classification. So if it is a regression, the target variable will be the continuous, and if it is classification, it could be discrete. And apart from that, the unsupervised learning won't have unsupervised learning won't have any thing called a target variable over here. So when we see here, we have some, if you assume a data set without this column, there were multiple information about age, sex, and multiple things over here, and we were not aware whether a person is having disease or not. In such scenarios, we say it as a unsupervised learning. And unsupervised learning, by using unsupervised learning, we can able to group based on something called as clustering. um, so here I have given a list of data sets available over, and so like you can go into Google search or ask ChatGPT about the data set available, and based on the requirement you can collect the data. But the best practice is collecting the data through with the help of and medical practitioners um, uh, or doctors would have a better impact. Yeah, so would have a better impact. And so these are the list of data sets available, and the first data set we are seeing is a COVID data set. It has the info of uh, what amount of death happens, recoveries happens during COVID-19, and this comes under the category of a regression problem. And this is the data set which is called as heart disease data set. And this data set says whether a person is having heart disease or not. So this is a data set available. This is actually the heart disease data set. So since here we have the category 0, 1, 2, 3, 4 as a target column, this comes under the classification problem. And another one data set, which is a diabetes data set, that says whether a person is having a diabetes or not. And apart from that, there is a bunch of data sets available, like World Health Organization, from Health Organization, from United States Cancer Statistics, and again World Health Organization. So normally in real time, so if you download the dataset from the Kaggle, you have something called a Kaggle dataset and target column, and apart from that you'll get info of the dataset. So when we go into the website, I can show you. If we go into the website, you can see the info, like what are all the columns available, and the info regarding that. So if there is a column called FBS, if fasting blood sugar greater than 120 milligram per DL, it comes as true, or else it is as false. So we have some info of the data set available, but in real time, it's up to you to choose what are all the features you want. Uh, and based on that, the data collection should be done manually. We can't able to we can't expect the data set in a predefined manner. So this is the sample data set. So here it is a cancer data set, says whether a person is having, it's a breast cancer data set, whether a person is having cancer or not. So malignant and benign. So it comes under the classification problem. So if it is a regression problem, so as I said already, the target column will be the continuous data set, continuous variable. So when we see here, this is the charges are the target column. So based on the age, sex, BMI, children, smoker or not, and the region, the insurance charges were given. So this comes under the regression. In such scenarios, the machine learning algorithm tries to fit a line which is called as y is equal to f of x. Y is equal to f of x, and it tries to fit a line along with the data points. So here, whatever the thing available over here in the red dots are the data points. So if two variables were available, like if age and charges were available, then age is the x-axis and charges were the y-axis, and the algorithm tries to plot the point and find the best line, which is can be said as the function y. So y is equal to f of x. So if we try to find y is equal to f of x by fitting a line, that is by fitting a line on a continuous variable, we say it as regression. And if we try to separate data points, so when we see here, there are multiple data points over here. And if we try to separate the data points over a plane or a line, then we say that as a classification problem. So again, in both the scenarios, we try to predict something called y. We try to predict something called y is equal to f of x. So if the function is a line, aligns with the data point, we say it as regression problem. If the function is a line separating data points, then we say it as classification problem. And another one, as I said already, the unsupervised learning. So in both the previous cases, we have a target column. When we see here, we have target columns over here. And when we see here, we have target columns over here. If there is no target column, then we have some info which is not grouped in a proper way. In such scenarios, we try to group them based on the similarities, and that is called as the unsupervised learning. Okay, so overall, this is the comparison between regression and classification. Classification tries to separate the data points, and regression tries to align with the data points. So as I said already, the real-time data collection would be not as easy as we see in the Kaggle data set. We have multiple infos available over there in different places. So some will be available in the app, some will be available in the form, some info we can get from sensors, some from online, some from World Health Organization websites, and through web scraping we can collect, and everything should be combined, streamed, and a large data set usually be created in industry. It won't be normally a small set of data set. It would be like a huge data set, and there is a need of proper infrastructure to collect, process it. If it is in the form of Excel, like, so as you know already, we can get medical info in the form of images, text, and in the form of informations also. If it is in the form of information, and if it is in the form of Excel, something like this, mostly we have something called as SQL, and in the database all the informations will be stored, collecting from different sources, and from that we usually take the data, process it, pre-process it, and build the machine learning algorithms. So as I said already, we should collect the data. The data collection plays a major role. Better the quality of the data, better the data, we'll get the better predictions. The objective should be clear and the outcome should be precise. So the data collection is the key process, and we can have additional information like geographic information, something like from which zone the data is being collected, like what is the population, what is the BMI, average BMI, all those things can be collected. and we can go for the once the data is ready, and then we can go into the model building. So let me explain the phases over here. The first thing is we need to collect the data. So as of now, we have seen like how to collect the data, how to aggregate it, and in real time how does the data is being stored and everything. Once the data is being collected, and we need to clean the data. There were scenarios like there were maybe missing values, there may be wrong information. So all those things should be treated before giving into the model. So if there are any missing values, if there are any null values in the data set, that should be pre-processed, and then we need to train and we need to test and finally improve the model. So as of the data set I'm showing right now is having null data. So we can see here, so when we see here, there may be blanks available within the data set. And if there are blank values available within, so here there are blanks and everything. If there are any blank informations available, if there is any blank, we can't give it into the model. Either it should be treated or the entire row should be dropped. So all those things comes under the data cleaning. So as of now, any doubts so far?
Ma'am, they have inquired only about the data sets, ma'am.
Okay, fine.
Yeah.
So I think I can answer about the data set links and everything by the end. So if you have okay, so like I have worked on pneumonia data sets, and I have worked on pneumonia data sets, and I'll be sharing the info by the end. Okay.
Thank
Okay,
you, ma'am.
fine. So let's move on. Okay, fine. So next is data clean. In case of data cleaning, we need to treat the null datas. Uh, we need to treat the null datas. I guess someone asked. Okay, right. So first thing what we have to do is we need to treat the missing values, and there may be a chance of duplicates. There may be a chance of duplicates. A single, so assume that uh, instead of having something like this, multiple columns will be available. So in real time, a single person may not be collecting the data. Multiple persons will be collecting the data. So multiple person may collect a single information. As a result, duplicates may be available. All those repeated duplicates should be like the correct info should be considered, and others should be avoided. If there are any incorrect data types, for example, if this FBS is the fasting, like blood pressure of a blood sugar level of a fasting, if it is greater than 120 mg per dl, uh, then it's true or else it's false. So in such scenarios, if all the others are true and false, which is called as a boolean category, if something comes as 20 or 100, then the data type is not correct. So in such scenarios, all those things should be handled and treated. Apart from that, we need to treat the outliers. So there may be scenarios like, so for example, as most of your professors and teachers here, marks can lie between 0 to 100. If any student is having 120 mark, it may be a typo. It can be either 10, or else it can be 20, or else it can be 100. So like if the expected range is between 0 to 100, and if you get some value something like 120, that is called as outliers, and the outliers should be treated before giving into the model. And there were scenarios we can normalize the features. So for example, um, uh, so when we see this column, the minimum value over here is 0 and the maximum is 200. So there are some kind of normalization which helps in improving the machine learning algorithm. So here in this case, the maximum is 200 over here, right? So what does the machine learning algorithm will do is the minimum value will be considered 0 and the maximum value will be considered as 1. Based on that, scaling happens, which is called as min. பார்த்ததில்ல மாமா அவங்க அம்மா போட்டோ நான் பார்க்க நினைக்கிறேன் மறந்து போறேன் பார்த்து okay. So which is called as min-max scalar. And apart from that, there are multiple scalings available. There is something called standard scalar. So what does this do means it apart from having extreme ranges, will have a fixed range of value, which helps in improving the model precision and accuracy. So these are the things need to be done. If there is null values, that should be replaced. So there are multiple ways of handling the null values. So when we see over here, if the data size is small, we can't drop the rows. If the data size is high, um, if the data size is large, then in such scenarios we can drop the rows. If normally this null values can be replaced by 0. So before doing whatever the data cleaning process, this should be from the expert in that domain. The info filling, the additional info should be filled with the help of expert available in the medical domain. And there are some scenarios we usually replace with the average. So when we see here, the average value is 139.97. So if like there may be, so these null values can be replaced by 39.79. Or else there were scenarios we can do forward filling. So if this is empty and in the previous 120 is available, the 120 can be replaced here, and that varies for use case to use case. So forward filling cannot be used in our medical field since all the persons are different. There are no similar persons. But average can be applied and only with the help of medical expert. And it's better to collect, if we collect our own data, we can avoid such kind of things. And the next step is doing exploratory data analysis. So as we have seen already, we have seen how to clean and manipulate the data. Then once the data is cleaned, we should do data exploration. Something like how many number of, so this shows that how many number of rows and how many number of columns are available. For example, 100 rows and 10 columns, all those things. And the next is summary statistics. So in case of summary statistics, that gives an insight of what is the minimum value, what is the maximum value, what is the mean, median, mode, there is something called IQ or interquartile range. What is the first quartile, what is the second quartile, what is the third quartile, is there is any outliers available. All those things can be identified with the help of summary statistics, and identify zeros and incorrect values and replace it with the equivalent one. And then visualizing the data set. There are multiple plots available for data visualization. So here what we can say, like there are box plot, line plot, all those plots can help us to understand how does the disease impact. And we can go with, like here when we see this data, and when we go into the data's information available in the Kaggle data set, we have 5 different classifications over there: 0, 1, 2, 3, 4. So what does the data say here is, whenever this target column, this P2 equal to 0, it is called as no disease, 0. or else it is 1. So this is the actual target column. So when we see here, wherever 0 happens, wherever the target column, this is the actual target column given by the data set. Wherever the target column is 0, then we say it is a normal thing. Wherever the target column NUM is having 1, 2, 3, 4, then we say there is a disease in the heart. Okay, so this is the insight provided from the website, and based on that we can do the count plot. So as I assume most of you may be aware of what is count plot. So when we see here, the count of ones is 509. Okay, the count of 1 is 509, and count of 0 is 412. So the count of 0 is 412, and count of 1 is 509. So if we have a box plot with this, if you have a bar plot with this, that is called as the count plot. And apart from that, we can have box plot for outlier detection. So these are few of the insights available, some visualization plots. So what is happened over here is, when we see this data, there is a column called age, right? There is a column called age, which has value from 28 to 77. So in such scenarios, so we have value from 28 to 77. In this case, we a standard scalar is used, which represents -3 for 28 and +3 for 77. So by using the range, a plot is like histogram plot is given with the kernel density estimator, and while seeing the data, there is a curve something like this. Does anyone aware of this kind of plot in any kind of mathematical um, mm, with any kind of mathematical representation? Which kind of plot is this? Any idea what kind of plot it is? Okay, so this is called as a normal distribution plot. So whatever the data we take, there may be less number of peoples in both the extreme places. Like, so for example, if you take a classroom with the better students and with the students with higher marks and lesser scoring marks, most of the people will be in the average place, and less will be in the lower scoring range and higher scoring range. And wherever we take, such kind of distribution happens, which is called as normal distribution. And how many this is actually a count plot, how many number of male and female is available, and the distribution of cholesterol. And we have something called a column called data set, which has different categories: Cleveland, Hungary, Switzerland, and how much percentage contribution available over the data set. So this is actually a pie chart, and as we said already, in the target columns we have 412 zeros and around 509 ones. So all those things are the different kind of visualization technique which helps us to understand and view better the data sets. So apart from that, we can go for box plot for outliers. When we build a box plot, there is something called as available like this as a dots. All these things are outliers. Just a second. So the first plot over here is the relationship between, this is actually the target, NUM, the target column, with respect to age. So when we see here, we have heart diseased people and non-heart diseased people. So 1 represents there is heart disease, and 0 represents there is no heart disease. So in case of heart disease, the average age is higher compared to no heart disease. So these box plot helps us to give better insights. And when we come into the next plot, so this gives us an insight of cholesterol levels. So when we see here, the cholesterol levels for non-heart disease and heart disease is almost similar. The average value is almost similar. This is the mean value. The average is almost similar. Uh, so we can't come into a conclusion saying that if there is cholesterol, the heart disease will happen. So based on these plots, we can come into a conclusion that what likely happened, what may not happen. It gives better understanding of data and insights. So apart from that, we can go for scatter plot. The scatter plot gives the relationship between like how does the cholesterol and is there is any linear relationship, is there is any non-linear relationship. All those things can be observed through scatter plot. So this is actually the scatter plot. Any doubts so far?
No, ma'am. No, ma'am. Clear, ma'am.
Okay. Right. So the next is there are multiple different types of data available. So if we, I specifically chosen this data to explain about multiple data set, multiple types of data set. So when we see here, this is a continuous data set. And here, this is a categorical. We have two categories, male and female. And again, this is a category. And again, this is a category. This is a continuous. These three are categorical. And this is actually, okay, if this is true, it's a Boolean data set. It's a Boolean column. It has true and false. When we give this column into the machine learning algorithm, it automatically consider true as 1 and false as 0. And so here these are rounded off numbers, right? So it is considered as a int data type. And here we have whole numbers. And this is actually called as float data type. And when we go into the categorical columns, mostly if we give the data as it is, so normally we have to, if you want to train the model, we can train the model in such a way that um, as we all know, these are the, we can't go for id, we can't use id. It's something like a student's roll number, right? So we can't give id as an information. So this should be dropped. And from this data set, from the remaining, let me create a new sheet. From the remaining, we have converted this target variable into this target. So this is this p column, right? So this is the target column, and these are all the input features, right? So these are the input features, and this is the target column over here. And we can't give the data as it is into the model. Why? Because here is we have something called as categorical, like male, female, some text info is available. Whatever the model may be, whatever, even though the new LLMs, NLPs, all those things can able to understand the model in the form of numbers. They can't able to understand the text. So all these values should be converted into numbers before giving into the model. And there are multiple ways of doing that. So in case of sex, there are two different things. One is male and female. Okay. So in such scenarios, we go for something called as one hot encoding. We have a separate column by using a machine learning algorithm. We create a column called as sex as male and sex as female. If we do so, sex as male will be given once and sex as female will be given as 0 in for this column. And for the sex as female, sex as male will be given as zeros and sex as female will be given as 1. Okay, so if we do such kind of encoding that says that male doesn't have any relationship with female, we don't say male is greater than female or female is greater than male. So if there is no correlation between these two unique variables available within the column, then we go for one hot encoding. And in case of label encoding, where we go for label, I'll give an example for label. There is another one kind of encoding which is called as label encoding. So in case of label encoding, we give something called ranks. For example, there are some different grades A, B, C, D, E. Okay, so we know A is the highest grade, B is the second highest, C is the third highest, D and 5. In such scenarios, if we label something like this, we say that A is high and E is low. If such kind of things happening, that comes under the thing called as ordinal or ranking. In such scenarios, we go for one hot encoding. So here, the one of the best example I have seen in this data set is this CP. CP is nothing but the chest pain. So here we have 4 different categories: asymptomatic, atypical angia, non-anginal, and typical anginal. So I'll keep a copy over here and drop duplicates. Yeah. So when we see here, based on the readings I go, asymptomatic says that CP is nothing but chest pain. So asymptomatic says that there is no symptoms. So I can give 0 or 1 here, the least over here. And non-anginal means there is a chest pain and not because of heart failure or muscles in the heart. So I can give higher score over here. And typical, atypical means there is chest pain and there is no classic patterns available over there. So I can give 2 here. And typical angina is due to heart muscle failure or heart disease. I can give 3 here. So like this is actually called as label encoding, and the label encoding can be used only if there is any relationship between the categorical information available over here. Got it? So is everyone clear where we have to use one hot encoding and label encoding? Okay, so apart from that, we understand the data by its distribution, whether it is normally distributed or not, whether whether it is aligned to the left or whether it is aligned to the right. How what is the dispersion? We say it as dispersion. What is the average? All those things should be analyzed before building the model. So when we go into the model, actually model building takes a less amount of time. Like we don't need to teach the model, it will learn by itself, but most of the time would be spent on cleaning the data set and understanding the data set. Okay. So as of now, we have covered what is data cleaning, what is data understanding. Once this is done, we need to train the model and test the data. So training and testing. If a data is something available like this, as I have said already, these columns should be these are the training info, these are the input features, and this is the output column, target column. So what actually should be done is we should check the null values. Wherever the text is available, it should be converted into an equivalent numerical value. Uh, if the column is true or false, obviously the model consider it as 1 or 0 since it's a Boolean column. Apart from that, if there are any unnecessary columns, so in our case, we have something called ID over here, which is an unnecessary column. All those columns should be dropped. And finally, we have around 921 rows, right? So normally we divide the data set into two parts. One is training data set and testing data set. So training data set gets around 80% of data, and testing data set around 20% of data. There are multiple splits of splitting the data into training and testing. So this is one of the way, and apart from that, there are something like out of time splitting data and out of bag. So most commonly used is out of bag, which is like splitting the data into training and testing, and it varies based on the use cases also. So the first thing what we have to do is we have to split the data into training and testing. So training, testing. Again, this training will be split up into two things: X train of input feature and Y train, which is the output feature. So here, if like if from here to here, if this is considered as a training data, this can be said as X train, and this much can be set as Y train. The remaining 20% can be considered as X test, and the remaining this much can be considered as Y test. So normally what we usually do is we have a machine learning model. The model will be trained by giving these inputs, by giving these columns as input, and will be trained on this column, and we'll give the model the input features of this, which is the testing features, and we'll expect the output from the model. It may give something like 1 1 0 1 1 0. So these may be the predictions from the model, but this is the actual one, right? So this is the actual one. So finally, we will score based on the values available from the model output. So this is the overview of how we are going to do the training and testing. So here, let's have a small lookup of what are the different machine learning algorithms available. So as I said already, machine learning algorithm find the relationship between the input parameters. So here X is the input parameter, Y is the output function, finds the function between the input parameter and the output. So, and machine learning algorithm can be broadly classified into two different kinds of algorithm. The one is parametric and another one is okay. One is parametric and another one is non-parametric. So parametric defines the function. For example, everyone may aware of the may aware of the equation y is equal to mx plus c, right? A straight line formula. If we can able to define a formula by using a straight line, that is called as by using a function. It doesn't need to be a straight line. It can be whatever maybe. In such scenarios, we say it as parametric algorithm. If we can't able to define by using a standard equation, we say it as non-parametric algorithm. And there were scenarios we can go for parametric algorithm. Like when the data is simpler, smaller, easier to understand, we go for parametric algorithm. And when the data is complex and if the data size is large, we go for non-parametric algorithms. So as I said already, if we can able to define a model, this is the model straight line. If we can able to define the model by using an equation, we say it is parametric. If we can't able to define by using an equation, then we say it is non-parametric. And in case of linear regression, there is a concept called best fit line. So if this is the data points available, the model tries to fit a straight line within the data, and it tries to find the best line, okay, where there is lesser error. So the best line, there are mathematical understanding behind that how it is happening, but if you go for Python coding and everything happens internally, but it's better to have the mathematical understanding behind how the best line is being suited out of different lines. So the best line is chosen based on the best model, like having lesser errors. Okay. So apart from that, this is simple linear regression algorithm, and if we can try to create a curved line by using a polynomial regression. Ax square plus bx plus c, ax cube plus bx cube plus c. So as the number of orders increases, cube power 4 from 2 to 3 to 4, we'll get a better curve. But the problem here is it leads to something called overfitting. So if there is something called overfitting, the model will perform better in the training, but it won't perform better in the testing. So something should be considered to avoid overfitting. So there are multiple algorithms available. So these are the top 8 algorithms. So there is something called linear regression we have seen now. There is something called logistic regression, which is meant for classification. So this is meant for regression and this is meant for classification. Logistic regression try to create a sigmoidal point between separating two different lines. Apart from that, decision trees, random forest. There is something called each and every algorithm has its own, it performs well at some places. It performs well at scaling. Some performs well at having as a raw data. Each and every algorithm have their own advantages and disadvantages. Few may be less time computational, and some other few may be highly computational. Um, and everything so the basic thing we should know in applying predictive analytics over into the data set is two things we should know. The first is we should know the data very well, and we should know how the math behind or how does different algorithm works. And once we are clear with how does the algorithm works, how 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 come the data is available, based on the correlation or understanding between the data and algorithm, we need to find the best model. We need to implement the best algorithm. So in real time, there is nothing like there are 8 different algorithms available. There is something called hyperparameter tuning. Based on that, within the model, we can create multiple data sets, multiple models. So it's better to have data understanding and algorithm understanding so that you can achieve better precision and recall and accuracy within the data set within a smaller attempt. If you're not aware of the algorithm and if you're not clear with the data understanding, we can achieve the model performance, better model accuracy and performance, but that take more amount of time. Okay. So as I have said already, the first we need to we need to prepare the data into training and testing. We need to train the model. So for training the model, we need to know the different algorithms. Based on the different algorithms, you can train the model. And by using the, for example, if you are applying logistic regression, okay, if you are applying logistic regression, the same logistic regression should be used on the test data set. So as we have seen over here, so we have a black box which is called as logistic regression. We are giving this as an input, and this is a target variable, and we are training on the we'll be training on the test data set and predicting on this data set. Um, so when we test on the data, this data set, the same logistic regression should be applied. We can't go for some other or different data set. Okay, so we can there are multiple ways of improving the model. We can create different features. For example, uh, the from these insights, from these categories, we can give additional information to improve the model performance, which is actually called as data engineering. So, so these are the overview steps involved in model building. First, we need to understand the data set. We should go through the data set, understand the data set, load the data set and clean it, do statistical analysis, perform EDA and visualize the data set. And we should interpret our observations. So one of our observation is in case of heart disease, lower age people has less heart disease compared to the higher age people, right? Which is obviously true. And we can able to see with the help of box plot also. And apart from that, then we need to prepare the data. Preparing the data, apply machine learning algorithm and measure the performance of the model. So we are aware till this point, I hope, and we'll be continuing from step 7. Okay, so if this is the data available, what we have to do is we have to split the data into training. So if this is training, this could be testing. This can be tested as training input, and this can be training output. And similarly, this could be the training testing input, and this could be the testing output. We need to split the data accordingly. So first we need to split up into train and test, and then we need to split up at training, testing, and training input and training output, testing input and testing output. So for the use case I have used here, the basic model in classification is the logistic regression model. And I would like to, someone in the chat asked for any guidelines available for learning this chart as I am new to this. So if you go into, most of them are available in website. If you go into this data set, this link, I can share this link in the chat. Okay. If you go into this, there is something called code available over here. So here you can see multiple persons given their insights over for the given data set. So when we see here, there are multiple sources available, like they are checking for null values. And as I said already, null values were replaced by median or most frequent. And as I said, right, we have a target column, right? So we have a target column which is 0, 2, 1, 3. Wherever it is 0, it should be replaced by 0. Wherever it is 1, 2, or 3, it should be replaced by 1. Those operations were performed here. And they did something called as min-max scaling and split it up into training, testing, check for null values. Okay, and these are the plots as we have discussed. If you go into like multiple sources available, so for this specific data set, you can go into the website and browse it. You can able to get multiple so in case of this, in the Kaggle data set, just a second, many people have given their insights. You can go into this, and if you have basic Python understanding, you would be able to understand this code, or else it's straightforward. Python is not a difficult language. If you go into if you do step by step, obviously you can able to understand it better. I hope I have answered one of the query. And so like we can build a machine learning model, when we see this code, this is like at this line we are declaring what kind of model we are using. So here I'm using logistic regression. Then after splitting the data into training and testing, I'm training the model. This is the model. Logistic regression is the model. I'm training the model by using a keyword called fit, and predicting based on the test data set. So once this is done, the model can able to give the predictions. So be having the predictions, we'll be having the actuals, comparing the actuals and predicted. We can able to evaluate the model. So as when the actuals and predicted are same, if the actuals and the predicted are same, we say the model has predicted correctly. If it is different, we say the model is not predicted correctly. More the number of correct predictions, we can say it as it's predicted correctly. So when we see here, the actual is 1 and the predicted is 0. When we see here, there may be scenarios where actual is 0 and predicted is 1. In such scenarios, we say it as faulty predictions. If the actual and predicted are same, we say it as correct predictions. And in case of since the data set we have considered is a classification. For classification, we have something called accuracy, precision, recall, and F1 score are the matrices. Okay, so this can be identified by using something called as confusion matrix. So here the positive is no heart disease, no HT, and negative is having heart disease, HT. Okay, so if 0 is predicted as 0, then most of them will be falling under, so this is HT. Okay. If 0 is predicted as 0, we say it as true positive. If 1 is predicted as 1, we say it as true negative. If 0 is predicted as 1 or 1 is predicted as 0, we say it as false negative and false positive. And it's our objective to increase this number and to reduce this number. Okay, and based on that we calculate the accuracy. So normally the accuracy will be the total number of data points, 31 plus 36 divided by 31 plus 31. I will have a formula here. So the formula for accuracy is 31 plus 36 divided by 31 plus 36 plus 0 plus 1. So in this case the accuracy is 91%. And most of the scenarios will be focusing on precision and recall. Precision says how useful the search results are, and a recall says how complete the results are. So each and everything has its own advantage, disadvantage, and based on the use case, we have to choose the precision and recall. Okay, so we can calculate the accuracy is the overall thing, and the precision and recall as calculated at class level, which is called as no heart disease or heart disease. So precision 0 means precision for no heart disease. Precision 1 means precision for heart disease. Recall 0 is recall for no heart disease, and recall 1 for heart disease. Okay, so and the average of precision and recall is considered as F1 score. Okay, so we can have something called as classification report. The classification report says it gives the entire report. If we have a syntax something like this in Python, it gives the classification report entirely, which shows like how many number of data points available, how does the model performs at different levels and everything. So the challenges in epidemiology is like the data gaps. Most of the scenarios we have incomplete or inaccurate data sets, and in case of emerging diseases, it's difficult to collect such infos immediately. So if like in future, if everything is digitalized and if the data is available throughout, we can able to do wonders. And like if we have the images, right, normally we can't apply machine learning algorithms in images. If we have your normal laptop can be used, CPU is enough to build a machine learning algorithm. If we have images, we need to go for high computations. In such scenarios, Kaggle has its own GPU. We can go for Google Colab. If we have to apply machine learning algorithm over images, we should extract features and convert it into a tabular column. Then only we can able to apply machine learning algorithms, or else we can go for deep learning algorithms such as CNN, ANN, multiple algorithms is on live just now. like if you have the images and if you have insights over it, better to go for deep learning algorithms, RNN, CNN, uh, multiple segments, semantic segmentations, everything's there. If you have, or else if you really want to, if you are having less computation and if you're having CPUs, then you have to extract features from the images and create a column, create a data frame, create an Excel with the target column, then you can do the predictive modeling. So this is all from my side, and epidemiology is the future in technology which helps in better health health understanding and health it can improve the human life, and by combining medical field and the engineering AI technology, we can able to do wonders. And any queries?
Participants, yeah, participants who can post your questions on the chat box. Already, ma'am has seen by herself some of the questions and she has answered, and she has given the data set also for UCA heart disease. Ma'am, Vishalini ma'am is repeatedly asking the data set for pneumonia, ma'am. She might be interested in
Okay, so
getting the history of patients. Likewise, the data set
I
should
I
contain.
worked it's like I worked on pneumonia dataset, and I worked on the Kaggle dataset available over the internet. So if she can able to post her email ID, and I can help her in sharing the data set with her. But if she searches over internet, she should be able to get it. And the pneumonia data set I worked is a Kaggle data set.
Kaggle data set already have posted, ma'am, but she has replied to that as she needs uh, what is that? She has replied that she has need the patient history data set, ma'am. And that is the data set that is which is there in the Kaggle is something like an X-ray data set. But ma'am has replied that she
Uh,
needs patient history data set, ma'am. Is
the
there any
info
way
is
to?
also the like if the data is available along with that, the information will also be available, which is in the form of metadata set.
Okay.
Like when I was working on this data set, along with that, I had like I can help her in sharing my GitHub profile. Uh, just a second. I did EDA on that, so I'll stop sharing and GitHub profile. And it was like I did over a long duration of time. Okay, I can't able to log in right now. Else, okay, let me share my screen again. So actually, I download from Kaggle dataset and worked on it with EDA and okay. Okay. Anyway, I can't able to, like, if she can able to reach me through mail, I'll post my uh, email ID in the post. Just a second.
Participants, as your request, we have unmuted. You can unmute themselves and you can ask the questions directly to the ma'am.
Hello, am I audible, madam?
Yes, sir.
Good evening, ma'am. A very
Brainy
informative
ma'am,
session, ma'am.
questions the participants is directly asking to you, ma'am.
Hello.
Yes, yes, sir.
Good evening, ma'am. This is Vinay here. I am from Karnataka.
Okay.
Thank you so much for the very informative session, ma'am. Actually, we are very new to this research and all. Actually, I'm working on breast cancer, ma'am. So I'm searching for the data sets. I found some data sets like RSNA data set. But there in the data set, I found the images, but I'm not getting the information related to that, ma'am. Is there any possibilities? Can you help me on the?
Yeah, I have seen some data sets available, but the info won't be available. So I have worked on similar cases. So what you have to do is you have to get no other go. You should get the domain knowledge. So if the data set doesn't have information about the disease, it's better to reach a doctor and get insights from them, or else we won't able to proceed with the, like, with an assumption we can't able to. So it's better to approach a doctor, or else you should go for some other different resources having the info of the images with results. Out of these
So,
two, we can't go for anything,
okay.
and the domain knowledge is must. We can't assume. Uh, so this is actually the real problem available right now. There were various websites where images were available, even RGB images were available, but the info, like, not the patient's info, whether the
Yes,
images is are images comes under benign or malignant,
yes, madam.
that info itself is not available. So I have seen that, but no other go. You have to approach a doctor.
Okay. Thank you so much for the information, ma'am. Ma'am, I have one more question. Ma'am, if you want to apply, like do the, like for example, I'm working on detection of breast cancer. So if I
Okay.
want to apply deep learning techniques on that,
Mm.
so what is the minimum number of images I require, ma'am? Is there any standard?
Right. So normally, if you're going for medical imaging, there is something called data imbalance. Have you heard of it?
Actually, I'm very new to this. I'm
Okay, fine. So, what does data imbalance means? We have diseased images and we have non-diseased images. In real
okay.
time, non-diseased images count used to be large compared to diseased images. This is
Okay.
called as data imbalance.
Okay.
So normally, equal number of diseased and non-diseased images should be there. If it is not there, if you are having only one diseased image and 1,000 non-diseased images, it's difficult for the model to understand. So
Okay.
whatever the data you choose, there should be at least, it depends on the scenario. Now, like, minimum of 100 images should be there. More the number, better the model prediction will be. And if in case if you have imbalanced data set, it's better to
Okay.
go for, there is something called data augmentation. You can
Okay.
create multiple images with the same diseased images. So you can convert the imbalanced data set into data set, and then you can train the model.
Okay. If it is a balance, my question is that if it is a balanced data set, ma'am, what is the minimum number of images we need to have to train
It
that?
depends on the use case. It depends on the way you train the algorithm. Multiple things are there. It's not a straightforward answer saying like 100 or 200. More the number, better will be. But the problem here with health is it's difficult to collect more images.
Yes, ma'am.
So you have to live with whatever you have. So as much as you have, it's better.
Okay. Ma'am, and I have one more question. For example, if we reach out to the hospital and we collected the images from the hospital, then what is the next procedure we need to do, ma'am? Like we need to do like pre-processing steps and all that. Like how it should go, ma'am.
So once you receive the data, like they can able to support from their side with the help of the domain understanding. And in a particular use case, when I met a doctor and asked them, like, how come you say this is a, like I worked on diabetic retinopathy, the doctor can able to explain me very well, but I was not able to understand. So in such scenarios, you have to document it. But after that, once that is done,
Yes.
their part is over. Okay.
Yes,
And
ma'am.
we have to go with pre-processing, if it is a color image, that should be converted into grayscale, extracting insights, removing noises, doing pre-processing steps, setting up the proper structure, proper um, layout, like the image size is 1000 cross 100. You have to create, you have to downscale the image, or you should create a bigger architecture based on the image size. All those things is our part.
Okay. Yeah. Thank you so much for the clarification, ma'am.
Thank you, sir. So I have given my email ID in the chat. So whoever needs any help can reach me out. Any other query?
Participants, mute yourself, unmute yourself. You can ask your questions.
Can you please share your email ID once again?
Already shared is there, ma'am. Already shared in a chat box. Please, you refer that.
Okay, madam.
Any other participants? Any clarifications you want to discuss with the ma'am? Let me know. Chitra ma'am?
Yes, ma'am, I'm here.
Yes, I
Well,
think,
let us conclude.
yes, ma'am.
Okay, okay, fine. So I think no more questions from the participants. So I sincerely thank Brenny ma'am for sharing valuable inputs to us to give us regarding the machine learning, how machine learning have been used in this medical field. Thank you so much, ma'am. Thank you for your inputs.
Thank you so much, ma'am. It's great time spending with you all people in the late evening. Thank you everyone for being on time. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Participants, please stay in the meet. The next guest has to be joined soon. Please stay in the meet.
Recording stopped.